I appreciate everybody hanging in there for me this afternoon. I know a lot of people have competing with the outside world. It's a nice day outside. One of the burning questions a lot of people have when we talk about Oracle, particularly in this show, is what the heck are you guys doing here? You know, you're a database company. What are you doing at a communications show? So let me tackle that one right off the bat. Oracle is about 140,000 employees. But within that grand company, we have industry-focused business units. We have things like finance and healthcare and hospitality. But we also have one called communications that's really focused exclusively on communications. The people here from Oracle are all in that business unit. We're the business unit that acquired Tekelec for the signaling components. We also acquired Acme Packet for the session management. And we also had a number of components already in the business unit before we acquired those. A lot of OSS and BSS components, as well as a lot of the application server components. So when you look at it in the whole, we have a very broad spectrum of communication products for the CSP marketplace as well as the enterprise. So moving forward, our today's topic is leveraging Wi-Fi calling to reduce operator costs and improve the customer experience. For over 70 years, W.D. Grant was a retail institution in the United States with about 1,200 stores across the United States. In the 1950s and 1960s, the company was oblivious to the fact that middle-class Americans were moving out of downtown locations to the suburbs. This is unfortunate for a company like W.D. Grant, who had most of their stores in downtown locations. Because of the fact they're no longer able to serve their customers where they were, they offered a very poor customer experience. As a result, after 70 years in business, the company went bankrupt, which at the time was the second largest bankruptcy in U.S. history. Much like serving the customer where they are affects customer experience in the retail business, it also has the same impact in mobile. It turns out about 80% of mobile calls occur indoors. And studies from Telecompetitor indicate that 74% of those people would change operators readily if they get better coverage at their home and in the office. And also IT decision makers indicate that 61% feel they really don't have very good coverage in their offices. Bad experience actually lead to churn. It's not just about making people happy, but that's losing your customer and losing revenue. I can speak to this from a personal standpoint. If you look at the coverage maps for where I live in my home, it should be blanketed with coverage. There shouldn't be any problem at all. However, inside my home, I have zero mobile coverage. My only alternative for my carrier was for me to spend $250 to buy an extender, technically a femtocell, so I could have coverage in my home, which I felt very frustrated that I had to spend that money to do that. If I had an alternative from another carrier, I'd very readily have been a churn statistic. We talked a little about the customer experience. Next, we're going to talk about things like the communication service provider challenges. We're going to talk about Wi-Fi calling, some security concerns, and then we're going to talk about the product work communication mobile security gateway, which is used in the Wi-Fi calling space. First, let's talk about some of the challenges. We all know, we've seen the Cisco VNI numbers of the growth of data that's occurring in the network. Well, this does impact congestion on the RAN. It turns out 80% of dropped calls really originate in the RAN. And also, as we all know, that one frustrating drop call is enough to really have a serious impact on customer experience and churn. Also, operators are constrained by the fact they can't just go out and build out their network with infinite capacity just to service people at wherever they are, because it does cost money to build cell towers and costs money to buy spectrum. So they have to keep their expenses really in line with their revenue. Indoor coverage and capacity planning is one of the most difficult things for operators to contend with, particularly of modern building architectures that leverage reinforced concrete and double glazed windows that really prevent signals from penetrating from the outside in. If you look at it from the standpoint how this impacts large buildings like hotels like this, it turns out that 54% of adults that end up going to a hotel with bad cell phone coverage will not return to that hotel. That has a material impact on the business. Adding towers and spectrum could be a solution to the problem, moving from an outside in. But the average cost to build a tower is about $150,000. And last year in the auction, $45 billion was spent by carriers just on spectrum. And working from the outside in really is not effective at penetrating into the core of buildings to provide good indoor coverage. So let's talk about Wi-Fi calling for a minute. Wi-Fi calling is cheap and it's everywhere. We've heard the other day that things like access points cost in the hundreds of dollars. And quite often, if you're leveraging one that's owned by your customer, it doesn't cost the operator anything. It's a free cost. Also, unlicensed spectrum doesn't have a cost as well. It turns out that the coverage capacity is very efficient for Wi-Fi as well, and reports from Sensifield Consulting and mobile experts indicate that is the best coverage per dollar of 100 kilobits per square meter per dollar. But we talk about Wi-Fi, didn't we really try this before? Yes, there was an effort with UMA, and everybody talked about that, and somebody mentioned it yesterday. Handset support was required. The architecture tended to be somewhat complex and expensive, and realistically, handoffs really didn't work that well and actually was removed from the specification. Fast forward now to what we call Wi-Fi calling. Device support is still required, but it leverages an investment that you already have in the Evolved Packet Core and your IMS. So it's not adding anything new in that category. And also it takes and does handovers that work just like LTE and macro cell handovers. So it works the same way between Wi-Fi and LTE as it does between cells in the LTE space. So if device support is still required, just like we had in UMA, why is it we're talking about this now and what's really changed? Well, it's about Apple. Apple really impacted and made the change. Simply by Tim Cook making the announcement that in iOS 8 and also the iPhone 5S forward would support Wi-Fi calling as a native capability in the hardware and the operating system, that sent a spark for the industry that recognized that this handset manufacturer is going to do it, other ones are going to compete with it as well. The handset ecosystem is now evolving and becoming in place. The iPhone now supports it, and now a lot of the Android ecosystem is now supporting it, particularly at the higher end of the Android ecosystem. And if you combine these two ecosystems together, they cover about 94% of the smartphone market. That doesn't mean every phone has the capability right now, but as they're moving from the higher end phones down lower ends, it'll cover very large coverage. The good news is they fundamentally follow the same capabilities. They have the IR92 capability. They support what's called interworking wireless LAN capability as a 3GPP specification, and also support the IPsec tunneling to provide the connectivity. So they're all very similar in the way they implement it. And also recently, Windows Phone has now joined the foray. So you get the major manufacturers supporting Wi-Fi calling. So what is Wi-Fi calling? The objective is really to provide the same mobile network experience that you have over Wi-Fi. Sometimes when I do a demo, I start off and say, this is going to be an extremely boring demo because it's going to be very, very familiar to you. It's not going to be anything new. And that's the beauty of it. There's no change in the customer experience. I can use my same phone number. I can use the same dialer. I can receive calls and get the same caller ID with it. And it's totally independent of whether I'm Wi-Fi or LTE. I also then can transition calls seamlessly between LTE and Wi-Fi as well, or from Wi-Fi to LTE using standard handoff procedures. And because we're no longer using an application, we're using device capabilities, the battery consumption is significantly better. I use Wi-Fi calling at home. I have my operator who offers it. What's nice about it is it was just provided to me in the iOS 9.3 update. I actually used the beta first so I could try it. And just all I do is turn a switch in the settings to turn Wi-Fi calling on, and boom, it was available. I then connected onto my Wi-Fi. I can use the same dialer, same phone number. And when I call and speak to my colleagues, a lot of times I don't know if I'm on Wi-Fi or if I'm on LTE. I have to look at my phone and look at the indication in the upper left-hand to say which one I'm on. The only way I might know is that the quality might actually be a little bit better than I would get on mobile network. Wi-Fi calling really satisfies the indoor coverage problem. It provides that enhanced indoor coverage to solve the problem you have inside of buildings, in your home, and in your office. Another thing it can solve in terms of customer experience is those annoying roaming charges you get when you're traveling internationally. Because it's over Wi-Fi, and we mean any Wi-Fi, not a carrier Wi-Fi, you now have an ability as a carrier to rate this call either as a free call, as a local call, or charge how you feel like you want to charge for it, but it could potentially be significantly less than roaming. So it offers significant customer experience from the standpoint of no longer be banged with these large roaming charges. From an operator's perspective, I no longer have to make those investments in cell towers and spectrum, so I can reduce my cost. Also, I'm able to leverage the investment I've made in my Evolved Packet Core and my IMS, because all those same services that I'm building on my IMS are immediately available over Wi-Fi as well. If I'm a cable or ISP, as we heard yesterday, they look at this a little bit differently. On the one hand, the CSP is looking at the macro network and using Wi-Fi to fill coverage gaps, particularly indoors. The ISPs and the cables are looking at it from the opposite side. They're saying, I'm going to provide Wi-Fi first wherever there's Wi-Fi, and I'm only going to go to the macro network when I have to, when there's no longer Wi-Fi available. And this is something actually they're able to set in terms of priorities of preference of one over the other. So I find, for instance, my carrier, who's an MNO, tends to prioritize LTE, even though Wi-Fi might be available. And sometimes I can force it to go to Wi-Fi by just turning on the airplane mode. And I can get onto the Wi-Fi calling that way, just because I like to play with it and learn how it works. Communication service providers also have views on Wi-Fi calling. We did a study with Rethink Technologies. It turns out that by 2020, fully 70% of MSOs, the cable operators, and up to 85% of the MNOs, mobile network operators, plan to deploy Wi-Fi calling. And why is that? Coverage. 30% is coverage. Breaking down between filling VoLTE gaps and indoor coverage, 30% are using it to really fulfill coverage gaps. It's important to note that this study was of 62 mobile network operators. So the Wi-Fi first, they point out there, is only 5% of the reason. My argument is if this was of MSOs, that would be a significantly larger number because Wi-Fi first is a very important thing for like cable and large ISPs. The Cisco VNI numbers support the view of Wi-Fi calling being a trend. The interesting thing is if you look at the 2016 report that recently came out and compare it to last year's 2015 report. 2015 report that said voice over Wi-Fi is a wild card. And actually in VoLTE, they projected to be at 41% by 2019. That's in terms of 41% of the minutes. Now, in the most recent report, they're only projecting VoLTE to be 26% by 2020. So a significant drop-off on the importance of VoLTE overall and when you compare it to things like voice over Wi-Fi. Now, I think this is largely because voice over Wi-Fi really has a wider device support, including things like Wi-Fi tablets, for instance. Operators are also recognizing the value of Wi-Fi calling. There's a GSMA report card at the end of February. They indicated that 17 operators have launched this capability across 10 different countries. This is the end of February, and in a minute, I'm going to talk about another operator that one of our customers has just deployed last month that adds on to this number, making 18 deployments in 11 countries. Some of the ones that are already deployed are up there: Sprint, Verizon, China Unicom, Rogers, Everything Everywhere, 3UK, and Vodafone UK. Wi-Fi calling is supported in the Evolved Packet Core. The cool thing about it, it leverages what's called an Evolved Packet Data Gateway, or the EPDG, to develop an IPsec tunnel all the way from the mobile core out to the end device. That allows you to treat Wi-Fi as a radio access network in parallel with LTE, allowing you to place and receive calls and receive the same service you had over LTE, and also be able to hand off between LTE and Wi-Fi in a very similar way as you move between cell sites with an LTE. It's important to point out Wi-Fi calling doesn't have any impact on data. So if I'm browsing the web or doing email, that's not going to be impacted because Wi-Fi calling only deals with what's called the IMS APN. So all the data is still going its normal way in terms of ad hoc Wi-Fi. It's also important to point out that Wi-Fi calling really does not require VoLTE or LTE. I could deploy this just to provide coverage issues and better indoor coverage. Then when I actually decide I want to have a VoLTE telecommunication application server and roll out some of my VoLTE services. Maybe I didn't put up all my LTE towers. I can start whetting the appetite for my customers by providing them some of the VoLTE services over Wi-Fi. So when I do deploy all the LTE towers, they are now familiar with them and build some stickiness to the service. And then when I have full VoLTE and LTE, I now have the ability to hand off between Wi-Fi and LTE in a similar fashion. So security concerns. When you bring up things like Wi-Fi and the internet in terms of a mobile network operator, sometimes the hair starts on fire. You think about man-in-the-middle attacks, eavesdropping, all these denial of service issues, unauthorized access, session hacking. They're all serious concerns for valid reasons. You also have situations that the Wi-Fi access points are often insecure locations. Could be in a coffee shop where it could be subject to hacking and tampering. Somebody could listen in, eavesdrop, break into that, maybe cause problems in your network by using it as access into your mobile core to create havoc. The Oracle Communications Mobile Security Gateway implements Evolved Packet Data Gateway. And the good thing about it is the Evolved Packet Data Gateway establishes a secure tunnel all the way from the core of the network out to the end device. This prevents those problems you have in the coffee shop of hacking into the Wi-Fi access point because you have a secure tunnel all the way to the device. So there's no way they can get in and listen to it or eavesdrop on that line. Also, because Oracle's implemented this EPDG based on a lot of our vast knowledge that we've learned from deploying the category-defining SBC in the marketplace, we're very familiar with edge security problems. So we can deal with a lot of the overload protection and denial of service protection issues. Also, since we're leveraging a lot of 3GPP procedures, we can authenticate and authorize or other methodologies as well. Now, a lot of people take a look at the EPDG and say, Wi-Fi calling, I'll just take that and I'll put that into my packet gateway. Just jam it in there, make it part of the product. We're in the camp, we don't think that's the right solution for several reasons. One of which, a standalone EPDG really follows the architectural model of the separation between the serving gateway and the packet gateway, since the EPDG is very similar in context to the serving gateway. Also, by separating, you have better scalability. Also, the EPDG, as a separate element, allows you to develop lots of IPsec tunnels. And if you're going to deploy Wi-Fi calling at scale, you're going to need lots and lots of IPsec tunnels, because the IPsec tunnels are not just established during the call, they're established for the session. So at this particular point, you have the ability to develop large amount of IPsec tunnels at a standalone EPDG, and you also have the ability to then add additional EPDGs to scale. Typically, packet gateways are not really attuned to deliver a lot of IPsec tunnels. That really wasn't their purpose. And also, Wi-Fi calling is continuing to evolve. You can imagine new requirements coming down the pike. Those changes and those requirements can now be isolated in EPG without impacting the packet gateway. Lastly, and probably one of the most important issues, is security. The PGW, by its nature, is a core network component. It is not an edge component. EPDG is, in fact, an edge component. So you have different security concerns at each point. The PGW is not built to deliver the kind of security required. The EPDG is focused on that. As I mentioned previously, this is built using our product called the Mobile Security Gateway. It's built on the session border controller knowledge that we've built over many, many years of deploying these session border controllers at the edge of the network. We leverage a lot of that knowledge so we can provide a lot of the denial of service attacks and various other kinds of threats that occur to the core of the network. We're not alone in this thinking. It turns out the survey done by the mobile network operators indicated 48% indicate a standalone EPDG is the right way to go, with only 28% leaning towards an integrated approach, and the requisite 24% of undecided. We've had some success with this product, the Mobile Security Gateway. This was just a use case that was originally introduced at the end of 2015, and we have a customer that's recently deployed as a public reference, the Telefónica Brazil. They've added as a complementary capability to the 2Go. This allowed, they were the first country in a telco in Latin America, and also the first country for Telefonica. It was launched on the 21st of 2016. The interesting thing was, once they've launched this, because of the customer experience change from what they were doing before with just their application and their ability to incorporate a lot of iPhones, they had 80,000 new subscribers between March 21st and April 1st. Obviously, the customer is very happy with this result. Also, they've received a much positive press in the industry and also a lot of social media activity around this. As I mentioned, the Oracle Communications Mobile Security Gateway is an EPDG for Wi-Fi calling. But in addition to that, it supports two other use cases. One of them is Wi-Fi offload, and the other one's a femtocell security gateway to support small cells. We deliver this on an appliance. Our thinking right now with an appliance with the state-of-the-art technology to deliver the wire speed performance, the large number of transcoding and decoding that's required. Purpose-built equipment can most cost-effectively deliver this capability. Doing this in software virtualization, yes, it can be done, and we will do that. However, at this point in its state of technology, it requires so many commercial off-the-shelf boxes to achieve it, it would not be economically feasible to achieve the large number of IPsec tunnels you require. We offer this in 3 packages, ranging in differences from 250,000 IPsec tunnels up to 1 million IPsec tunnels, and also differing in numbers of physical interfaces. As I mentioned before, this has 3 fundamental use cases: Wi-Fi offload, Wi-Fi calling, and also small cells. It turns out the Wi-Fi calling was just introduced at the end of last year, but prior to that, we'd introduced this for these other 2 use cases for quite a period of time. And we have 20 Tier 1 and Tier 2 operators with this in operation today supporting their networks. Unfortunately, like some of the other people have mentioned, some of these operators are sensitive and do not like their names disclosed, but nonetheless, there are a lot of the ones that you are familiar with. The Oracle Communications Wi-Fi calling has a number of related components. In addition to the one we're talking about now, the mobile security gateway, there on the left-hand side of the screen that performs the EPDG functionality. We also use our SBCs for access SBC functionality and proxy CSCF functions. Also, an additional IMS component is our core session manager, or CSM, which is available in virtualized or physical component, and this is an interrogating and serving CSCF function. Moving to another product is the VoLTE Telecommunication Application Server. This is a product, it's not one of my products, but it's an interesting product to me because it supports all the IR92 services out of the box. In addition to that, it provides a wonderful lifecycle management from the time of development all the way through deployment to be able to retract and add services automatically in one particular location. If you're at a trade show and you see it demonstrated, I suggest you spend a little time looking at this because it's a very impressive capability, not just for this, this industry space, but for some others as well. Then if you have diameter traffic, we have a DSR, diameter signaling router, that allows you to untangle a lot of the diameter traffic. And if you happen to go to a legacy network touching SS7 networks, it's most likely you're going to run into one of our other products, the Oracle Eagle SDP, providing SDP functionality for SS7 networks. So in summary, Wi-Fi calling allows you to improve voice coverage, improve the customer experience by providing that same experience you have on the mobile network, allows you to decrease churn, to maintain your customers, and also because you're leveraging unlicensed spectrum and you're leveraging commercial off-the-shelf equipment, and you're leveraging Wi-Fi access point, you can mitigate the macro RAN investments. Allows you to introduce some of your VoLTE services prior to LTE rollout to leverage some of your EPC and IMS investments and create stickiness for VoLTE services. And then also enable some service innovation with things like video calling and Wi-Fi first MVNO support, and also wireline substitution. Recognize a lot of people today, including myself, have a fixed line in my house. The reason I do is because of unreliable mobile coverage. I'd be very happy to get rid of that capability if I had the ability, if I knew I'd have reliable coverage in my home and in my office. Also extend services out of market. This is a very important capability because now you're no longer bound by where your cell towers are located, that perimeter. You now can extend beyond that to where any Wi-Fi and offer service to your customer wherever Wi-Fi exists. And also because you're not allowing an application to come up on the phone with its own branding you're staying in front of the customer with your services as the operator to retain mind share with your customers. So with that, I'm done, and a word from our lawyers. Thank you.
Steve, please stay just for a couple of questions.
Okay.
I want to thank you also for not starting by reading the lawyer's statement, by the way. But it's great to have you. It's a great presentation, and
Thank you.
one of the best Wi-Fi calling presentations, honestly, I've seen. So the interesting thing, I think there's a number of interesting things, but the security issue is a big one. I think
Absolutely.
there's a general misconception
Right.
that people think that Wi-Fi calling for some reason is insecure. The way that Apple, who kicked this off essentially
Right.
on the device side, decided to do it is actually completely secure, and you're
Right.
furnishing the other end. Is that not correct?
Yeah, it's that right, but it's also it's the standards that come about.
Right.
It's really a 3GPP standard. Apple adopted that standard, so we can't give all the credit to
No,
Apple.
no.
We give Apple the credit for taking the impetus to put it in their phones
Yes.
to support it, but nonetheless, they basically kicked it off in the industry.
Right. And right now, your status as far as actual deployments, you mentioned Telefonica.
Yep. We're engaged with a number of customers. Some we can't talk about. The one we can talk about is Telefonica, who recently spoke with us at our Oracle
Right.
Industry Connect event in Florida last week. So they've publicly communicated this information, so there's something we're able to share.
And maybe no surprise they're going in that direction, because I know also, having been in Latin America, how important Wi-Fi is for folks down there,
Right.
and how hard it is to get coverage inside, because the networks down there are struggling sometimes, right?
Yeah, and it's all about, and a lot about the customer experience. And using an
Yeah.
application from their perspective was not the same experience they have by using
Yes.
a native capability. Also, they weren't able to really effectively do that on the iPhone. This allowed them to do the native dialer, same phone number on the iPhone as well, which is also very important for their market.
Any questions? Last questions for Steve? There's one.
Actually, I'll start the other way around. You talked about Wi-Fi calling as also being appropriate to MSOs and Wi-Fi first MVNOs, but
Right.
the description of the architecture, right, has
Sure.
this thing leveraging the EPC and IMS core.
Sure.
So you're essentially saying that these guys have to implement an EPC and IMS core.
Well,
Is
that's
that
certainly one way. They could be effectively an MNO and deploy all that, or they could have a relationship with an MVNO as an MVNO and then basically connect into it at various points. So there's multiple different architectures we're exploring with some of the cable operators, but I don't believe that the strict 3GP architecture is the only way to deploy it. There's going to be other ways to deploy this, particularly for cable operator, particularly if you're making concessions on if you don't want to do a handoff to the LTE network, you're happy with a nomadic customer rather than a mobile customer, for instance. So there could be trade-offs that one architecture should lean more towards one architecture than another.
Any other questions for Steve? There's one. Great. It's over there. And there's one and there's one behind after, but don't worry. Let's go over this one first.
A quick question on physical MSG implementation for EPDGs now with the, a lot of the industry trends saying do NFV or,
Absolutely, yeah.
VMware stuff. So, you can do everything in there. That's what the claim is. So, and you have come up with a dedicated box to do security offloading. So can you comment on your strategy versus what other people are saying?
Absolutely. I mean, first of all, NFV and virtualization are enormous efforts within our company. Almost every product is focused on virtualization with NFV. If you go to any other conferences, one of my partners is right now speaking at an NFV conference, talking about our VNF manager, our network service orchestration capability. So we're very much focused on this, having all our ability to do all these different virtualization function within the context of NFV. Absolutely very important. However, we feel the current state of the art to deliver this from a cost-effective standpoint. Not that it's hard, not that it's impossible to deliver, but if you're going to deliver something like 1 million IPsec tunnels, to do that on COTS hardware may not be economical. So we're saying we don't believe right now the state of the art is such that we can do that. We are working very closely with our ecosystem partners like Intel on trying to figure out how we can leverage commercial equipment to achieve that. And it may be, according to the people tell me in the lab, maybe a few years out yet. But we will have both. Actually, we will introduce a virtualization capability for some smaller opportunities.
I think it's because there's a lot of buzz obviously around virtualization. I think it's sobering that you actually have the view that let's make it practical now and then move to that later, because a lot of it has been hyped up, right?
Well, when you talk about wire speed, you talk about things about jitter. I mean, you're making a phone call. I mean, if you get jitter, it's not going to be a very pleasant phone call, right? It's not going to really work. So if you want to work with high quality, these kind of, the purpose-built equipment is really built to do that. It's all about doing the very fast setting up of IPsec tunnels, very fast encryption and decryption, and all this trying to do it at wire speed, and to do it for 1 million channels simultaneously.
There was a question behind there. Yeah.
Apple chose to do this in the operating system, whereas Android still seems like it's OEM or even carrier specific. Are there plans for Android to include the functionality directly in the operating system?
I think right now, you know, the Android ecosystem is a little bit different. Every one of the operators takes the OS and they work with the, for instance, a handset manufacturer like a Samsung or whatever. It's really within that venue is where they're making the decision how they want to incorporate it. So it's a little more fragmented. Obviously, iPhone's more of a closed system, but the Android ecosystem, so it's really up to a handset manufacturer to decide how they want to incorporate it, and there are some variations in how they're doing that. I'm not aware of any operating system-wide through Android to do that.
Okay, last question for Steve. Steve, I want to really thank you for coming. I want to thank you for supporting this event. It's super important for us. And I want you to stay for just 1 minute, because this is actually